Hey everyone, have you ever wondered how different coasters compare in terms of speed, height, and other features? So, today we are going to explore a dataset that reveals some interesting insights about these thrilling rides. So, let's get started. Our goal is to understand the trends and patterns in roller coaster data. So, we will look at the various attributes such as speed, height, year introduced, and location. So by the end of this tutorial, you will have a better understanding of what makes the roller coaster so fascinating and how they have evolved over time. But first, let's talk about the some challenges we might face. Roller coaster data can be tricky because of inconsistencies like duplicates and missing information. This can make our analysis a bit messy, but leading to unreliable result. We will also need to balance different type of data and including numerical and categorical data, which can be a complicated things. So here's how we are going to tackle this challenge. First, we will start by cleaning the data, removing any duplicates and filling in or dropping missing values. Then we will also rename some columns to make them easier to work with. And once the data is cleaned, we will dive into some visualization to explore key attributes. This will include bar charts, scatter plots, or even correlated heat map. So these tools will help us spot trends and relationship between different coaster features. Right. Now, let's set up our data analysis environment. We are using key libraries like Pandas for data manipulation, NumPy for numerical computations, and Matplotlib with Seaborn for beautiful plotting. We are also applying the ggplot style to our plots for a clean look. To keep things neat, we turn off some common warnings to avoid clutter in our output. Okay, so now let's get import the libraries. Okay, now let's load our dataset from a CSV file into a data frame so we can start exploring and analyzing our data. Now let's find out the size of our data to see how many rows and columns we have in the data frame. Now let's randomly pick 5 samples from our data frame to get a quick look at some of the data points. So the result shows that we have a variety of roller coasters in our dataset. with information about their length, speed, location, status, opening date, type, and many more. So these 5 samples include details like coaster names, their speed in different units, heights, and even the numbers of inversions and g-forces. It gives us a good snapshot of the diverse data we will be analyzing, right? Now, let's list the column name to see what kind of data is available in our data frame. So, here the result shows that we have a lot of information about roller coasters, from basic details like their names, length, speeds, and more specific data like manufacturers, height restrictions, and g-forces. This list of column names gives us a good overview of the type of the data we will be working with, right? Okay. Now let's check the data type for each column to understand what kind of information we are dealing with, whether it's text, number, or dates. So the result shows that our dataset contains numeric information about roller coasters. The data tells us that the average coasters had about 1.5 inversions, with some having as many as 14. The typical speed is around 48.6 miles per hour, but the fastest coasters can reach up to 149.1 miles per hour. The mean height of the coasters is about 102 feet, but there are some touring one that go up to 377 feet. So this summary statistics gives us a sense of the typical characteristics of roller coasters and their variations, right? Now let's keep only the key columns in our data frame, focusing on essential information. Now let's convert the opening date clean column to a date format so we can work with as a proper date rather than just text. This will make it easier to perform date based analysis and calculations. Okay, now again check the data types for each column to understand what kind of information we have. Now let's rename some of the columns header to use more consistent and readable names and making them easier to work with in our analysis. Now let's check for missing values in our data frame by counting the number of non-values in each column. This helps us identify which columns might need cleaning or handling for missing data. Now let's identify all the duplicate rows in our data frame to find any data that appears more than one. Now let's check for duplicate roller coasters by looking at the coaster's name column and then display the 5 first duplicate entries to see which one are repeated. So the result shows that we have a duplicate roller coasters in our dataset that shares the same names but with different details. For example, Crystal Beach Cyclone and Derby Wrecker appears in multiple rows. These duplicates suggest we might need to clean or further investigate the data to ensure the accuracy. Now, let's find all rows in the data frame where the roller coaster is named Crystal Beach Cyclone to gather more information about this specific coaster. Okay, now again let's list all the column names in our data frame to see what kind of information we have for each roller coaster. Now let's remove duplicate rows from the data frame based on a unique combination of coaster's name, location, and opening date. Then reset the index to maintain a clean dataset. Now let's count how many roller coasters were introduced in each year to see which year were the most active for new coaster launches. Okay, now let's create a bar plot to visualize the top 10 years when roller coasters were introduced. Right. So here this portion basically, right? So this portion we are counting the occurrence of each unique values in the year introduced column which gives us the number of roller coasters introduced in each year, right? And then we are selecting only the top 10 years with the highest count of roller coasters introduced, right? And then this portion, right? So this plot is kind equal bar. So this portion basically we are creating a bar plot using matplotlib, and the bar plot kind basically specify the types of plot, and we are selecting the color of the bars. It's my own custom color, and then adding black edges for better visibility, and the title of the plot is set to be top 10 years coasters introduced, right? And then the x label x axis label is these lines set the label for x axis to year introduced, and the y axis label set the basically the label for the y axis to count, right? Now let's create a histogram to visualize the distribution of roller coaster speeds in miles per hour, right? So here the first line generate a histogram plot for the speed column with 20 bins, and this represents the speed intervals, right? And the plot uses teal colored bars with 70% transparency. Basically alpha means the transparency, right? Then black, we use the black edges, and title we set a coaster speed, right? And then the same thing, we set x-axis label to speed to indicate what the histogram represents. Okay, here I just missed the color code, right? Okay, so the first line generate a histogram plot for a speed column with 20% B, and this represents the speed intervals, and the plot uses teal colored with a 70% transparency and as usual black edges and the title set these things, right? Okay, now let's plot a kernel density to visualize the distribution of roller coaster speed in a smooth curve, right? So here the first line creates a KDE plot for the speed column which shows the distribution of speeds as a continuous curve. The line is drawn in a purple with thickness of 2, and the plot has a title that says coaster speed, right? Now let's execute it. Now let's count the occurrence of each type of roller coaster in the type main column to see which type are the most common in our dataset. We have 728 at steel, then 191 at wood portion, and others are said to be 71. Right. Okay, now let's create a scatter plot to visualize the relationship between roller coaster speed and height. So here basically this line sets up a scatter plot and choosing speed for x-axis and height for y-axis, right? And then I just print it. So here I just made a scatter plot with a twist by using color to indicate the year each coaster was introduced. So here the first line creates a scatter plot with speed on the x-axis and height on the y-axis. But it also uses a hue parameter to color the point based on the year introduced. So here I just add an extra layer of information to the plot showing how coasters from different years compare in speed and height. Okay, now let's execute it. Now let's create a pair plot to explore relationship between multiple numerical variables and use color to differentiate by the main type of the roller coaster. So here the first line set up a pair plot with 5 variables: year introduced, speed, miles per hour, heights, inversions and g-forces. So these will generate scatter plots for every possible combinations of these variables and then helps us to identify potential patterns or correlations. And the hue is equal type mean these parts add the color to the plots based on the type of roller coaster. So this helps to see if different types of coasters have distinct relationship among these variables. Okay, so now let's calculate the correlation matrix for our key numerical variables after dropping any missing data. So here this creates a new data frame called df core, and this selecting specific columns, that is year introduced, speed, height, inversions and g-forces. So this removes rows with any missing values using drop null method. Then the correlation functions calculates the correlation between these variables, and this results in a matrix that shows how closely they are related, right? Okay, so the result shows that there's a strong positive correlations between roller coaster speed and height. So this indicates that taller coasters tends to be faster, and g forces is also positively correlated with speed and height. And this suggests that faster and taller coaster delivers strong g-forces. On the other hand, there's a negative correlation between year introduced and inversions. This means newer coasters might have fewer inversions. So the overall these correlations gives us a sense of the relationship between different coasters characteristics. Okay, now let's create a heat map to visualize the correlations matrix with added color and annotation. So here the line uses seaborne heat map function to plot the data frame correlations as a heat map, and the annotation is equal to this parameter means display the actual correlations values in each cell and then making it easier to read the numbers. And the CMAP argument is set the color scheme to a gradient from cool to warm, which helps to quickly identify positive and negative correlations. Okay, now let's create a horizontal bar plot to visualize the average speed of roller coasters in different locations and considers only those locations with at least 10 coasters. Okay, so here this line basically filter out rows with other in the location column, and this ensures we are working with the specific coaster location. And the group by function, this part basically groups the data frame by location, allowing us to calculate statistics for each location. And the aggregation here, mean and count segment, basically calculate the mean and the count of speed miles per hour for each location, and this provides the average speed and the number of coasters in each location. And then here the query function, right? So here the query, here I have said count is greater than or equal 10. This basically selects only the location with at least 10 coasters, and this gives us a more reliable sample size, right? And after that, the sort value, this function basically sorts the locations by their average coasters speed in ascending order and prepare the data for plotting. Right? Now let's execute it. And that's a wrap. I hope you enjoyed this exploration of roller coaster data. If you found it interesting, don't forget to like and subscribe for more content like this. And let me know in the comment section which roller coaster data insights surprised you the most. Or if you have any other question or topics you would like me to cover. Thanks for watching, and I will see you in the next video.